Okay, I'm making this video to more explain about what is t-test. So t-test, here you can see there are only 9 samples and the data is given for these 9 samples. Let's see the what is the question is 9 individuals are chosen at random from population and their heights are found 62, 72, 65, 67, 66, 65, 68, 70 and 68. Discuss the suggestion that the mean height in the universe is 65 inches. Means here you can see the data that are coming from the 9 individuals are actually the 9 individuals are selected from their population and whose mean height was given as 65. Means universally the height is reflected at 65 inches and they are asking whether these 9 samples height is different than those which is given as 65. So one can say here the samples are lesser than 30. Even the standard deviation of parent population is not given, so we can use here t-test. But which t-test? Paired, unpaired, single mean? So the answer will be single mean, because the only one group of sample has given here. You can see the 9 individuals that they are representing here, they have reflecting only one group. If they are have if they are comparing with the other group, or if the difference of the mean we have to find out with comparison with the other group, then we can say we will use paired or unpaired t-test. But here the comparison is between the parent population, so only one group is given and there will be only single mean of that group, which we have to find the difference with the population group. So that is the basic understanding of the questions. Now what is how to formulate the hypothesis? As we know 1 minute. Yeah, as we know, for formulating the hypothesis, we need to generate the statement. The statement can be generated either by paired or by two-tailed or by one tail. So here they have generated the statement with two tails scenario, like the mean height in the universe is 65 inches. As you know, for null hypothesis we have to judge the situation with the unbiased nature. So for creating the unbiased nature, we have to make the situation equally for for parent as well, parent population as well as sample. So here they have make the statement like the mean height is equivalent to the universal mean height, that is 65 inches. If this condition proves, then our answer will be the sample will be coming from the parent population. But if it is not, means the sample the question has reflecting is not coming from the parent population. So that is the exact meaning of this statement is. Now what is a two tail and single tail? If we are comparing the situation with situation like greater than or lesser than the others, then we can say we are in a single tail situation. But if we are taking this as equal to or not equal to, then we are comparing the situation with the two tail situation. So here we are making the sense that we are not making here statement like greater than universal population or lesser than universal. We are making the statement whether it is equal or not equal. So it is two tail situation. Now let's see what is the solution of this example. So now you can see here the formula for t-test is t is equal to x bar minus mu upon s divided by under root of n. So x bar is your sample mean. Remember, Population mean always we show with the notation mu. Sample mean we show the notation with the x bar. Why x bar? Because it is reflecting the sample mean, so the individuals we generally take it with the x notation. So finding the mean of x means we are taking the mean of the sample, and population mean is given as 65. Now you can see the basic difference between the formula of Z test and T test here is the S. S here it is used for the sample standard deviation, and in Z it was used for the population standard deviation. So basically we are testing the sample test for finding the difference between population mean and the given sample mean. So now for this formula, what we need to calculate here? For this formula we need to calculate x bar, which can be found out by summation of all the 9 individuals taking, and with the number of observation, that is 9, we will get the value of 67. Then how to find the S? S is a standard deviation, as I already told. The standard deviation, if you square the standard deviation, you will get the variance. If you get the variance, and for variance you can use this formula. For this formula to use, you need to calculate the summation of x minus x bar square. So this can be easily understood with this table. You have to find out every individual difference with the sample mean, and then you can see the summation by squaring all the values. You can take the summation of this 70. So 70 divided by 8 is n minus 1. You will take the value, get the values 8.75. Now T test by with the formula you can say the value is 2.03. Now for rejecting or accepting the things, you need to match this value with the observed value, with the observed value, observational value, or one can say table value. So how to find out the table value? You can say here the number of samples are 9, so degree of freedom will be n minus 1, so it will be 8, and you are finding the values depends upon which level, at 5% level or at 1% level. At 5% level you can see here with the table at degree of freedom 8 with a 5% level of t value. The 5% level of t value, the value is table value is 2.81. So why we are taking it as 0.05 level column? Because you can say at 5% level, if you divide 5 divided by 100, you will get the 0.05. If you divide it 1 divided by 100, you will get the value 0.01. So 0.01 means you are 99% at confidence interval with 1% level of significance. Now in both the values, if you can see here, at 8 degree of freedom you will get 2.81. At 1% of significance level you will get the value of 3.35. But the calculated value you have taken here is 2.03. So lastly you can say 2.03 is lesser than those two values, which is either 2.81 or 3.35. So one can say the values are reflecting the fact that null hypothesis is acceptable. If the calculated value would have been like 3.82 or more than 3 point something, which is reflecting here in table 3.35, if it has been greater than 3.35, or even for the 5% level of significance, if the value would have been 2.81 greater than, then you might have say that the hypothesis is rejected. But for this condition, I think the values that is given here in a solution is incorrect one, but but the concept is, if the value is greater than the table value, then you reject the null hypothesis. Here in this case, the value is, if the value is lesser than the table values, that is why you are accepting the hypothesis, and that is why you are making the statement that accept the null hypothesis since t calculated is less than the t value for 5% level of significance as well as 1% of level of significance. So the conclusion is the mean height in the universe may be 65 inches. The difference occurs due to the chances of other things, the chances of errors of creating other things. The chances of errors, that is the statistical part, but for solving the example, I think this is sufficient to test the t-test with the table value to match the difference between the population and sample mean. Remember one thing, the population and sample mean can be solved, the difference can be solved with the z-test as well as t-test, but for z-test you need a larger sample size, even you need a population variance or population standard deviation there. But for t-test you need a sample size less than 30, and you can calculate the sample deviation from that sample size. Thank you.